Hi everybody, so look, this is bite-sized chemistry, part 2 for the octane number and processes, and we're going to look at 2016, and again, we're not going to be doing the full questions, we're just going to be looking at the questions that focus specifically on the octane number or their processes. So, looking at 2016, and again, they're always question 6s, we're looking at part D and E. So, on undergoing catalytic cracking, a gas oil molecule C18H38 is broken into 3 smaller molecules, each of which is a hydrocarbon. 2 of these hydrocarbons are octane and propene. Deduce the molecular formula for the third molecule formed. Okay, so break this up into smaller parts, guys. The easiest way forward for this. Basically, what we're going to be saying is, look, I'll write it up here, okay? The reactant equals the products in terms of the number of carbons and hydrogens. So the reactant we're dealing with was C18H38 equals, and there's 3 hydrocarbons. There is, yeah. So let's just start off octane. I'm just going to do a little side down over here. Octane, and again, that means oct, meaning there's 8 of them, so C8H. And again, for any of the alkanes, you multiply the number of carbons by 2, and then you add on 2. So 8 times 2 is 16, plus 2 is 18. Okay. Next was, let me see, propene. It's actually very similar to one that we did previously. I'm just going to have a quick peek at that one, see if it's almost identical to it. Was that one? No, it was over here. Yeah, so it's almost identical to it. Cool. Okay, C8H18 and propene, so there's 3 carbons in propene I should say, so that means C3, and for all the alkenes, you just need to multiply the number of carbons by 2 to get the hydrogens, so therefore it's going to be 6. Okay, so our products are going to be C3H6 plus C8H18 plus, and this is what we're trying to figure out now, X. Okay, so how many carbons are over here? So let's just break this up, and I might just do a different color mark for this. So we're going to do C, and if we count up our carbons, I should say, we have 18 over this side, and over this side we have 3 plus 8, which is 11. So 8 and 3 is 11 there. So 11 from 18 leaves us with 7. Okay, so in that case there, we're going to be dealing with, over here, it's going to be 7 carbons. Now, generally, when we do one of these, okay, and we get 3 products, it'll be 2 alkenes and one alkane. So that must mean then that it'll be H14 here. Now, double check it just to be sure. Let's count them up. We have 18 over here, 6 over here. 18 plus 6 is 24. You take 24 from 38, and you'll be left with 14. So our answer there, in this case here now, guys, is going to be C7H14. So how I did it again, just as a reminder, I remember that the reactants will equal the products because conservation of mass states that matter could not be created nor destroyed and all of that. We knew our reactant was C18H38. We were told 2 of the hydrocarbon products, octane and propene. I wrote out their molecular formulas over here just to figure them out. Some of you might know them off by heart, that's perfectly fine too. And if you don't know them off by heart and you can't remember the rules over here, then draw them and then count up the number of carbons and hydrogens. It'll take you a bit longer, but you'll be more likely to get 6 marks that way. And then I just knew that X had to be the remainder of the carbons and hydrogens, and that was it. Okay, so I'm going to go on to part E now. And let's read what E is asking us. So E, draw the molecular structure of octane, 2,2,4-trimethyl pentane, and ethyl benzene. Okay, we've seen these type of questions appear a few times now. So I think it was octane, wasn't this? It was octane. So the molecular structure, so look, you just draw out your 8 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8. And again, it's an alkane, so there has to be single bonds across the whole amount, and each of them are going to have hydrogens in it. And just to note here, guys, that you must put in your hydrogens over here. I know in school, when we're in class and all that, we sometimes just don't bother with putting in the hydrogens because, you know, obviously it's a little bit time consuming and we can be a bit lazy sometimes. But in your exam, you have to put in the hydrogens. Okay, that's critical. And double check it too. You'd be surprised how many students add on an extra carbon. It's actually really surprising how many add on extra carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So octane is here. Grand. Next, I think it was ethyl benzene, something like that. Oh no, sorry, that's part 3. Part 2 is 2,2,4 trimethyl pentane, and this is one of our reference hydrocarbons. It's actually a reference hydrocarbon of 100. So 2,2,4 trimethyl pentane. So start with the pentane. That means there's going to be 5 carbons in its longest continuous chain. It's obviously more than 5 carbons, but we're only counting the longest continuous chain for this one, which is pentane. And there's 3 methyl groups, and they're found on the second, 2 on the second one, and 1 on the fourth. So I'm going to put them in here, here, and here, and the fourth being here. So CH3, CH3, CH3. It's really important that you show the bonds between the carbons to the other carbons, not in the middle, not to the hydrogen, but carbon to carbon, carbon to carbon, carbon to carbon. That's so important. Now, all you have to do for the rest of us is just put in the hydrogens. Make sure each carbon atom is still an alkane, so there's no double bonds present, and you have to make sure each carbon atom has 4 single bonds. Okay, and that's it. Again, you can just count them up. 1, 2, 3, 4, 5 to show you. Once you get good at it, you won't need to be doing the numbers so often. So 2, 2, 4. That's 3 methyl groups, so trimethyl, and then the longest continuous chain is 1, 2, 3, 4, 5 pentane. So 2, 2, 4 trimethyl pentane. You do need to know how to draw that one. Okay, next is the ethyl benzene. So all you have to do for this is draw a benzene ring. Okay, no, it looks like a desperate benzene ring. Draw a circle in the middle. Some of you could do your double bonds, every second one being a double bond, perfectly fine. Ethyl benzene, ethyl meaning there's an alkyl group, and it doesn't matter which place you put it on. I'm just going to put it on here, and I'm going to write down C2H5. And that's it. Okay, C2H5 is our ethyl group. Okay, and if you wanted to draw that out properly, your C2H5, that's perfectly fine too. Okay, it doesn't matter how you do it. So look, that's the answer for 2016 there, which was tricky enough, certainly not the easiest, but once you can do them once, really, they do get that little bit easier, I suppose, and the rest of them are a bit more manageable. So we're going to go on to 2013. I know I skipped a few there, but like they're very repetitive, and I don't want to be doing the exact same ones. I'll try to vary them a little bit. So A, I'm not going to write this out because my writing is desperate, so I'm just going to call it out to you. Define the octane number of a fuel. So it's the measure of the tendency or likelihood to auto-ignite or to resist, a number resisting auto-ignition or something along those lines. Okay, so I always use it as the measure of tendency to auto-ignite. Or you can mention knocking there as well, instead of auto-ignite. So B is compound A, and where's A? Oh, A is here, and B here. And I'm just going to get rid of one part there while I see it. So I'll just change that, and I'll change that to white. Here, we're not going to be doing this last part over here, guys. Okay, so getting back to it, we're told there that compound A is obtained from fractional distillation of crude oil and is converted to B by isomerization. Give the systematic names for A and B. So look, let's just do that now. So I, And again, you must write it down and you state here A equals, B equals. You don't be leaving the examiner guess. So A, you can see here there's no methyl groups attached. So we just count up the longest continuous chain. 1, 2, 3, 4, 5. So 5 being pentane. Pentane. B. We can see if we count up the longest continuous chain, it's going to be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. No matter what way you count, left or right, it's going to be the same. Okay. So we know it's going to be, at the very ending of it, it's going to be butane. Now there is a methyl group attached to it, okay, over here. So we want the methyl group to have the lowest number possible. So if we count from left to right, that methyl group would have a 2, which would be the lowest number possible. So it's going to be 2 methyl, the 2 meaning the location of the methyl group, not the number of methyl groups. So 2 methyl butane. II. Explain the term isomerization. Again, I'm just going to call this one out to you guys and draw a structural isomer. We'll do that now in a second. Okay. So isomerization is changing the alkane or the hydrocarbon to another hydrocarbon while keeping the same molecular formula. Okay, so it has the same molecular formula, but and you must say molecular formula, and for this same molecular formula but different structural formula. So what we're doing for isomerization is we're changing the hydrocarbon A into hydrocarbon B. Okay, so the same molecular formula, different structural formula. Okay, it's only an explanation. You don't need to. It wasn't a definition as such. Okay, so for the description, not the description, underneath that, you're asked to draw a structural formula of another isomer of A and B. So another isomer of A and B here. Well, for alkanes, the easiest way to go for isomers is just to remove one CH3 at the very end and stick it in the middle. So I'm going to have a go at it now. So instead of having 4 as my longest continuous chain, I'm going to have 3 as my longest continuous chain. 1, 2, 3. I already have a methyl group here. And I said I'm going to stick one of the ending, the CH3 at the very end, into the middle. So that means it'll go onto this one over here. That means everything else has to have hydrogens. Now we're going to double check this, and I can't stress how important that is for these. To double check them, that they all have 4 bonds, that they have the same molecular formula. So we can see here that there's a different structural formula here. Grand. If we count up the number of carbons, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Grand. Hydrogens. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. If we count them up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're fine. We're good. Okay. C5H12 for all of them. Okay, so that is our isomer over here. Next, we have I and I done. Part 3, predict which A or B would have the higher octane number, and then to justify your answer. Okay, so B will have the higher octane number, guys, and the reason that's part of your answer, and the reasoning why it is more branched. That's it. Okay, it's more branched, or you could have actually said it has a shorter carbon chain length. Either or of those two would be perfectly fine to say. So either shorter chain, because it only goes up to 4 compared to 5, or it is more branched because it has a methyl group attached to it. Okay, and we'll leave it to that one there, guys, and we're actually going to do another one there. That's because that was quite short, and we'll do 2012 here, and you'll see that this is fairly similar as well. So let's start off 2012A. Several processes are used in oil refinery to convert less useful hydrocarbons to more useful ones. For each conversion, I to part 3, name the process involved. Okay, so this is A now. A. And we're on I, and I. Okay, so we can see for the first one, for I, we have dehydrosilylation straight off. And that's no brainer because we have the formation of hydrogen gas, but the main thing is the formation of the benzene ring. So dehydrosilylation. ION. Part 2. We're going from a long chain carbon compound to something that is to shorter chain carbon compounds. Okay, and the only one that you do for that is catalytic cracking. So part 2 is catalytic cracking. And finally, our part 3 then, we're going from a long chain carbon compound to something that is the same, but obviously it's more branched. So the methyl groups there. So therefore, number 3 there is isomerization. Okay, so we have A done. Let's look at B. Name a hydrocarbon that X would be and draw its structural formula. So X is over here. Name and state products. Okay, we'll do that now in a second. Okay, so let's do part B there. So guys, again, take it logically. We said it already in was it this video? It was actually the very beginning of it, that the reactants equals the product. In this case here, there's only one reactant, but there's multiple products. So let's draw them out. We have C14H30. So I will do that. C14H30 equals, and then we have C7H16 plus we have C3H6 plus we have to figure out how many carbons and how many hydrogens. So let's count them up. We have on the right hand side so far we have 7 plus 3 is 10 and we need 14, so therefore 4, C4 is going to be the answer here. And we want to find out what's the story with the hydrogens. Again, 16 plus 6 is going to be your 22. Oh, I forgot to put in the 30 here. And therefore 22 from 30 means it's going to be 8, C4H8, which makes sense because for any of these you always get, if you get 3 products, 2 of them will be alkenes. That means they're going to be a double bond in it. So C3H6 is an alkene, as is C4H8, because again the hydrogens are double the amount of carbons, and that's how you figure out if it's an alkene. So that was the C4H8 is the molecular formula, but was that what we were asked to do? It wasn't. You were asked to name a hydrocarbon that X could be and draw its structural formula. Okay, so X equals butene, but1ene to be precise. And we'll draw ours out. 1, 2, 3, 4, put the double bond there, and make sure that each carbon atom has 4 bonds. And then throw in the hydrogens. Double check at the very end to make sure your hydrogens, number of hydrogens and carbons align. Carbons obviously too, but counting up the hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8. 8. So this is our answer over here, guys. Not this, but this. Okay, but you couldn't get your answer without getting the molecular formula. I think there's another part to be. Name the product of the process, part 3, and state its octane number. Oh, so we have to name this guy over here. Okay, that's fine. So we're counting it there. Again, we want the carbons, methyl groups to have the lowest number possible. There's 2 on this carbon over here, and there's 1 on this one over here. So we want the 2 here to be the lowest number possible. So I'm just going to put a 1, 2, 3, 4, 5 to count from that side. And I can see here it's my reference hydrocarbon there. It's going to be 2,2,4 trimethyl pentane. So 2,2,4 trimethyl pentane, and that has an octane number of 100. Heptane is one that has an octane number of 0. It's a reference hydrocarbon that you just need to know off by heart. C. Explain why the substance MTBE is sometimes added to motor fuel, and the reason for that, guys, is to increase the octane number. And then name the substance previously added to motor fuel for the same purpose and state why its use was discontinued. Okay, so that substance there, guys, was the petrol. Sorry, not petrol. Was lead. Lead was added to petrol. But the problem with lead is it was a catalytic poison, which was a problem. So it destroyed the catalytic converters in cars. But not only that, it's actually toxic to humans and the environment. Okay, so toxic to humans there. I don't want people mentioning carcinogenic there. Okay, that's not really what we use anymore. It's much better to say toxic to humans and environment. Okay, guys, look, we've answered B and C there as well. Obviously, when I said there it's toxic to the environment, that's why it was discontinued. So when you look at your petrol stations and stuff like that, they often say unleaded petrol, just out of habit nowadays. Okay, so look, we've done a few questions there, and we'll do a few more in the next video. I hope that helps in terms of your understanding the octane number and the processes, and that you're starting to see a little bit of repetition, so that it makes things easier to remember for exams. Alright girls, best of luck. So